Hey, do the dishes. Why? Because I said so. Why? Stop asking why. F of X. That was funny. Y'all know it was funny. Abby sent me that one, so I had to throw that in today. So your warm-up for today is the average number of seeds in a package of cucumber seeds is 25. The number of seeds in a package can vary by 3. That means they can change by 3. What are the maximum and minimum number of seeds that can be in the package? Well, we're supposed to have 25. If it can vary by 3, that means I can have 3 more than 25 or I can have 3 less than 25. 3 more than 25 would give us 28. And then if I had 3 less than 25, that would give us 22. Now that's a pretty basic, simple kind of explanation, but this is the type of problem we can use absolute value equations for. The way that you do this is we're going to say, okay, X is going to represent the number of seeds in our package that we actually have. We're supposed to have 25, but the number that we actually have is some number X. Now, vary means the difference between them, okay? Vary is talking about the difference. It can be 3 up or 3 down. So the difference between X, the actual number of seeds, and the average, 25, the difference between those is 3. We don't know if we have 3 more than 25 or 3 less than 25. And remember, absolute value can go in either direction on the number line and still remain positive. So that is why we use this absolute value equation to model the situation that we have. Okay, let's look at another one. The Gallup poll shows that presidential candidate Josh is in the lead with 54% of the votes, plus or minus 4%. What are the maximum and the minimum percent of votes candidate Josh could actually have? So this is something that you could definitely see or hear about now that election season is gearing up. But they're saying that he's got 54% of the vote. It could be 4% more than that, or it could be 4% less than that. So if we start out saying 4% more of the vote, well, that maximum number of percentage points would be 58%, right? But if in fact they were wrong in the negative direction, 54% minus 4 would just be 50%. So he's going to have somewhere between 58 and 50% of the votes. How would we write this as an absolute value equation? Well, we would just say X represents the actual percent of votes that candidate Josh has. Okay. Now, if we want to talk about his actual percentage points and what their estimate is, the difference between the actual number and the estimate is 4%. Remember, we're going to use the absolute value bars because we don't know if 54 is greater than the actual number or if 54 is less than the actual number. So by taking the absolute value, we end up being able to find our answer in either direction. Now you're probably like, Ms. Guidry, what are you talking about? How does using absolute value show either direction? Let me show you. So we're going to practice solving absolute value equations today. The very first step when you are solving absolute value equations is to isolate the absolute value expression. We want to isolate the absolute value expression. So we need to get those absolute value bars and whatever is inside by itself. After we isolate our absolute value expression, we are going to write 2 equations. We're going to set one equal to positive C, and we're going to set one equal to negative C. So basically, what do I mean by that? Once we get it set up into our absolute value expression being isolated, we have this value over here on the right side. We're going to set it equal to the positive value of that, and then we're going to set it equal to the negative value of that. So that's our second step. Our third step is going to be to solve for X. So that's going to be our third step. And our fourth step is always going to be to check for extraneous solutions. What's an extraneous solution? It is answers that make your original equation false. All right, so here we go. Example 1. Step 1, we need to isolate our absolute value expression. Well, that expression is the absolute value of x minus 4. Is that by itself already? Yes, it is. So we're good. What does step 2 tell us to do? Step 2 tells us to write two equations. Our first equation is just going to be x minus 4 equals positive 6. We drop those absolute value bars. The second equation is going to be x minus 4 equals, and we're going to make the negative side, the right side of our equation negative. So x minus 4 equals negative 6. All right, we've done that. Now all we have to do is solve for x. So in order to get the equation on the left, that x value by itself, we're going to add 4 to both sides of our equation. And that gives us x equals 10. And then to solve the other equation, we're going to do the same thing. Add 4 to both sides of our equation. And that's going to give us x equals negative 2. So we've taken care of step 3. Step 4 is to check for extraneous solutions. What the what? All right, all you need to do is take your two solutions and sub them back into the original equation. So our original equation was absolute value of x minus 4. So instead of writing the letter x, I'm going to sub in the number 10. The absolute value of 10 minus 4 should equal 6. Well, let's check that. What is 10 minus 4? 10 minus 4 gives us 6. What's the absolute value of 6? 6. So does 6 equal 6? Absolutely. That means 10 is an actual solution. Take your second answer, x equals negative 2, and let's sub in our negative 2. The absolute value of negative 2 minus 4. That should equal positive 6. Well, let's check it out. Negative 2 minus 4 gives us negative 6. What is the absolute value of negative 6? That means what is the distance from 0 of negative 6? It is 6. 6 equals 6. So we have two solutions that are working. We have no extraneous solutions. Both of these answers are solutions. If you want, you're more than welcome to type that into your calculator and have your calculator tell you true or false. Okay? Example 2. When I look at this, it says the absolute value of 3x plus 1 equals a negative 5. So our step 1 is always to isolate our absolute value expression first. And when I look at that, I look at my absolute value bars and there's nothing else on the outside of them. It's just everything is on the inside. So we have isolated our absolute value expression. But I want you to recognize this problem right here. We talked about it on Friday. Absolute value always means distance from 0. Distance is always positive, right? Our distance is always positive. So can you ever have an absolute value equal to a negative number? Hopefully you come up with the answer no. Once you have isolated your absolute value expression, if it equals a negative number, if not a negative expression, not a negative variable, if it equals a negative number, you can automatically say no solution. Because an absolute value can never, ever, ever, ever equal a negative. Absolute value cannot equal a negative number. You should probably write that down on your note sheet, highlight it, star it, whatever. You've got to remember that an absolute value cannot equal a negative number. Oops. Okay, third example. It says the absolute value of 3x plus 9 minus 10 equals negative 4. So I look at example 3 and I want to isolate my absolute value expression. So here it is right here. What's next to it on the same side of my equal sign that we need to get rid of? Okay, I've got to get rid of my minus 10. So that's what I've got to do first, right? Let me enlarge this. So I'm going to say plus 10 to both sides of my equation. And we end up with the absolute value of 3x plus 9 equals Negative 4 plus 10, which gives us 6. So do we have our absolute value expression isolated? Yes, we do. So our next step is going to be to write our two equations. The first one is just going to be 3x plus 9 equals 6. So essentially, we're just rewriting the equation. We're just dropping our absolute value bars. Our second equation is going to be 3x plus 9. Again, we drop our absolute value bars, but this time we have to change the sign of this side of my equal sign. So a positive 6 turns into a negative 6. And now we're just going to solve. So I have 3x plus 9 equals 6. All I need to do is, subtract 9 from both sides of the equation. Get it together, Gidry. Subtract 9 from both sides of our equation, and that gives us 3x equals 6 minus 9 is negative 3. Then we're going to divide both sides by 3, and that gives us x equals negative 1. That's one solution. Now, if I go to our second equation, 3x plus 9 equals negative 6. We're just going to subtract 9 from both sides of our equation. And that gives us 3x equals negative 6 minus 9 is a negative 15. Divide both sides of your equation by 3. And that gives us x equals negative 5. So we have two solutions. We are not allowed to assume that they are both valid. We have to double check. So we're going to substitute both of those number values back into our original equation. So when I look back at the top, it says the absolute value of 3x plus 9 minus 10 equals negative 4. So that's what I need to rewrite. The absolute value of 3x plus 9 minus 10 equals negative 4. That's what our original equation states. Okay? It's right up here. The absolute value of 3x plus 9 minus 10 equals negative 4. So let's sub in our two answer choices, or the two answers that we came up with. The absolute value of 3 times x, but instead of x, we're subbing in negative 1, plus 9 minus 10 should equal negative 4. Well, what is 3 times negative 1? That gives us negative 3. Negative 3 plus 9, that gives us 6. The absolute value of 6 minus 10 should equal negative 4. Let's see. The absolute value of 6 is 6. Minus 10 more equals 4. So this is negative 4 equals negative 4. That is definitely true. Let's sub in our other answer choice. We're supposed to have the absolute value of 3 times negative 5. That absolute value minus 10 should equal negative 4 as well. Oops, I forgot my plus 9. Dadgummit. Hold on, guys. So sorry. So the absolute value of 3 times negative 5 plus 9 minus 10 should equal negative 4. So let's see if that works. What is 3 times negative 5? That gives us negative 15. So negative 15 plus 9 gives us negative 6. So this is the absolute value of negative 6. Minus 10 should give us negative 4. Well, what is the absolute value of negative 6? How many steps from 0 is negative 6? Well, 6. 6 minus 10 should equal negative 4. Is that the case? Yes. Negative 4 equals negative 4. That's true. That tells us both of our answers are correct. Neither one of them are extraneous. They are both correct. Okay? One more example. I don't know why this phrase that I typed up here keeps moving around. Sorry, guys. Let's look at this one. Example 4. Dude, get out of my way. It says 1/2 times the absolute value of x plus 6 should equal x. So first thing we got to do, always isolate our absolute value expression, which right now I have a 1/2 in the way. And anytime you want to get rid of a fraction, all you need to do is multiply by the reciprocal. Take the 1/2 and flip it. So I'm going to rewrite it right here so I have space. We have 1/2 absolute value x plus 6 equals x. So I need to multiply the left side of my equation by 2/1, or just 2. Okay? Whatever I multiply the left side by, I have to multiply the right side by. So 2 times 1/2, those reduce, and we end up with the absolute value of x plus 6 equals 2x. All right, so now I have my absolute value expression isolated. There's nothing else on the left side of my equal sign other than this expression. So we're going to have to write our two equations now. The first equation that we are coming up with is x plus 6 equals positive 2x. We just drop our absolute value bars. And our second equation is x plus 6 equals, and now we're going to make the 2x negative 2x. We're just changing the sign of one side of our equation, okay? So I need to get our x values by themselves. Right now on the left equation, I have x plus 6 equals 2x. I have x's on both sides of my equal sign. I don't want that. So I subtract x from both sides of my equation. X minus x goes to 0, and that means 6 equals 2x minus x just gives us x. There we go. We solved that side. Now if I look at my other equation, I'm going to get rid of my x again, subtract x from both sides of my equation, and that gives us x minus x is 0. That gives us 6 equals negative 2x minus x gives us a negative 3x. Well, my x value isn't alone yet. It's not isolated. So now I need to divide both sides of my equation by negative 3. Whatever I divide one side by, I've got to divide the other side by. Those negative 3's reduce, and that gives us, let me scroll up just a tad, that gives us our x value on the right side is equal to 6 divided by negative 3 gives us negative 2. So we have two answer choices that we need to check. We have positive 6 and we have negative 2. So we've got to go back and check for extraneous solutions. We have to go back to our original equation, which was 1/2 absolute value x plus 6 equals x. That's what's supposed to happen. So I'm going to take my first answer choice right here, x equals 6, and I'm going to sub it in. 1/2 absolute value 6 plus 6 should equal, and I don't want to write x, we're subbing in 6 for x right now. Well, what is 6 plus 6? That's 12. So I have 1/2 times the absolute value of 12 should equal 6. Well, what is the absolute value of 12? It's just 12. So 1/2 of 12 should equal 6. What is half of 12? 6. Perfect, that works. So our first solution is good. Now we're going to take our second solution of negative 2. So I have 1/2 times the absolute value of negative 2 plus 6, and that should equal negative 2. Remember, we're plugging back into this original equation right here. 1/2 absolute value, negative 2 plus 6 should equal negative 2. Well, let's break this down. Look at the inside of your absolute value bars. You treat those like parentheses. Negative 2 plus 6 gives us 4. So we have 1/2 times the absolute value of 4 should equal negative 2. Well, what's the absolute value of 4? It's just 4. Half times 4 should equal negative 2. What is half of 4? 2. Does 2 equal a negative 2? Absolutely not. So what does that tell us? Does x equal -2? Is that a valid solution? This right here? No, it is not. This is extraneous. This is an extraneous solution. And that is how you solve absolute value equations.